This time we're going to calculate pH from our Kb values. Remember, this is a dissociation constant for a base. So our base is methylene, and this is going to be one of your Bronsted-Lowry bases. So it is going to accept a hydrogen, so it doesn't look like your normal base. I'm going to pause this to write this. So your equation is the methylene ion plus water. Equilibrium arrows form CH3NH3 plus hydroxide. So we have a Kb value, and we need to calculate the pH of this 0.5 molar solution. So it's going to be like any other equilibrium. It's going to start with an ice table. Concentrations of our products are going to be 0. After equilibrium, we're going to lose some reactant and gain some product, and the amount of that is going to be determined by that K value. So you have 0.50 minus X, and both of these are going to be X. So from our equilibrium, our Kb value is going to be substituted in 4.4 times 10 to the minus 4th. And that's going to be products over reactants. So I'm going to have x squared over 0.50 minus x. So because the exponent of this is very small, I can just eliminate that minus x. It's going to be insignificant in comparison. So I'm going to cross multiply my values, and that is going to give me 0.5 times 4.4 times 10 equals x squared, and I just did all the math in the calculator, so x is going to be 0.015, which is your LH concentration. So I need to find pH, so remember POH is equal to the negative log of your LH concentration. So the negative log of 0.015 is equal to 1.83. Now, I can't stop there. You might remember that the pH plus POH equals 14. So I'm going to take 14 minus my 1.83. 14 is like a definition, so your sig figs will come from your 2 decimal places here, and that will give me 12.17 as my pH. And that's my final answer for that question. And for this problem, we have cyanide ion reacting with water to form hydrocyanic acid and hydroxide. And you'll see that this is a Ka value. This is actually a base. So we need the Kb value. So from your reference sheet, Ka times Kb equals Kw. So it's very simple to find this. So Kw is 1.0 times 10 to the minus 14th. And if we divide that by our Ka value of 4.0 times 10 to the negative 10th, that will give us our Kb, which is 2.5 times 10 to the negative 4th. And then once we have that value, it's just like the other problem we've done with an ice chart, so 0.20 molar cyanide ion to start, no product to begin with, subtract X, and add X on the product side. And our final is 0.20 minus X. And our products are both X. So we'll have X squared over 0.20 minus X equals 2.5 times 10 to the negative fourth. Okay, again, X is small, so we can delete that. And taking the square root of the product of 0.2 times 2.5 times 10 to the negative fourth is going to give you 2.2 times 10 to the negative third. And again, that is your OH concentration. So we're going to do POH and negative log of the hydroxide concentration, and that is going to give us a POH value of 2.65. And again, you should know that this is not a logical stopping point because we're doing a base, and 2.65 would be the pH of an acid, so then you're going to have to subtract the 2.65 from 14 to get the pH of 11.35.